So my name's Elise Shear. Welcome to the Hawaiian Department of Transportation's 2025 Protect Our Water Conference. I will be your moderator for this morning's session titled When Stormwater Meets a Contaminated Site, Risks, Realities, and Solutions. At the end of our presentation, the speakers will have a few minutes to answer your questions. Without further ado, I would like to introduce our speakers. Derek Sheldon is an environmental scientist working at the intersection of contaminated site characterization and stormwater management throughout the Hawaiian Islands. Derek has an additionally varied background, including indoor air quality assessment, agricultural management, and development of experiential educational programs and spirits production. Dennis Peters is a registered environmental manager with Haley and Aldrich, based in Honolulu, Hawaii. He brings over 35 years of experience in environmental planning, permitting, regulatory compliance, and site investigation and remediation, and solid and hazardous waste management. Dennis has led and contributed to a wide range of projects throughout Hawaii and across the Pacific Rim, delivering practical, sustainable solutions for complex environmental challenges. Please help me in welcoming Derek Sheldon and Dennis Peters. Good morning.
Well, good morning, everybody. We really appreciate you. Coming in to join our session this morning. My name is Derek Sheldon. As Elise mentioned, I am an environmental scientist with Haley and Aldrich, with going on almost 8 years in both residential and commercial industrial stormwater management. And I'm very pleased to share the dais this morning with Dennis as well.
Thanks, Derek. We're going to do a little tag team here, so I'm going to sit down for a few slides, but I just wanted to say how appreciative I am to be able to be working with the environmental section at the airports and bring together my 29 years in Hawaii doing basically contaminated site work and stormwater work. So this is a really great, fun topic for me. And thank you all for being here. And thanks to our coworkers who helped with the presentation.
So we really want to start out by giving the why for this presentation. Now, Brenda, wherever she says, gave us a really great background, and we really appreciate your presentation and how it was able to kind of set the foundation for what we're going to be talking about today. Ultimately, what we want to focus on here first is that managing urban stormwater can be a ubiquitous challenge in all aspects of the transportation industry. That can be for the government agencies that are planning and facilitating that management, for the designers, the contractors, the project managers, even ultimately the end users of our transportation sector. But stormwater can also be a tremendous resource that requires very careful strategic management that is oftentimes very context dependent. And we'll get a little bit more into that as we go. So oftentimes when we think about stormwater management, the focus comes to infiltration. Now, infiltration is more often than not a very desirable way to manage stormwater for recharge, for water quality, for things of that nature. However, site-specific circumstances, such as known or unknown contamination in areas exposed to stormwater, can complicate the benefits and oftentimes the plan for the management of stormwater in these areas. So what we really want to focus in on today are two key questions. And these questions are obviously deeply connected. You'll see that they're very similar, but oftentimes approached from opposite ends of the decision-making spectrum, maybe by two different teams of people who are a part of the same decision-making team. But ultimately, we have one goal, which is to prepare you to answer these questions by the end of the presentation, right? Begin answering these questions by the end of the presentation. So how are we properly going to manage stormwater without worsening the spread, discharge of contamination on the sites that we're in? And how do we properly manage soil and groundwater contamination to avoid adverse effects on stormwater and surface water quality? So as the basis for that, we want to talk a little bit about the contaminations that we may be seeing, or contaminants that we may be seeing. And like I said, Brenda gave us a really good rundown on kind of some of the things that we may see out in the environment. A non-exhaustive list is up on the screen here for you, but I wanted to touch on a few of them and basically how they're going to enter the environment by way of our transportation sector. So you've got things like nutrients and suspended solids. You've got your heavy metals, hydrocarbons, things that we may be a little bit more familiar with, and things that we may not, such as chlorinated solvents, PCBs, PAHs, PFOS, which is an emerging contaminant, and some other ones that we'll get into a little bit more later. So These contaminants, once they've found ways out into the environment, whether it be by erosion of unmanaged or mismanaged soil, through general wear and tear and the particulates that come out of that, industrial spills, misuse of contaminants or misuse of chemicals, potential improper handling or disposal of wastes. Once they make it out into the environment, they have the potential to mobilize beyond their source location. So the mobility of these constituents ultimately depends on a number of characteristics, including specific contaminant that may be discharged, the media that it was discharged into, be it soil, soil gas, groundwater, surface water, sediments, and other environmental factors that may include things like temperature, presence of organic carbon, co-presence of other constituents as well. And once these contaminants find their way out into the environment, they don't just necessarily stay right where they were or where they were discharged into, right? They have kind of a plethora of ways of really mobilizing beyond their source location. That may be through direct infiltration, one thing that we're going to really focus in on today, stormwater hitting a site, infiltrating through contaminated media and off the site into other locations. Mobilization of pollutants through constructed stormwater management structures, such as drainage wells, storm drainage systems, things of that nature as well. An oft overlooked one, including utility corridors, is potential bypasses that could be conduits for electrical or communications or water. And then once these contaminants find their way off of a site, they oftentimes flow downstream into ecological and human receptors that then can expose people or the environment to these contaminants. One last way that's a little bit less discussed is oftentimes that groundwater flows can also find their way back up into surface water. And we'll touch on that a little bit later as well. So thinking a little bit about how these contaminants are mobilized, we want to focus in obviously on stormwater and how it can mobilize contaminants. The infiltration that we see with stormwater, right? We said it's a beneficial reuse or beneficial management system. Can mobilize contaminants into groundwater or into streams or oftentimes into our nearshore environment. And erosion from mismanaged or unmanaged soils can mobilize contaminants into water bodies and uncontaminated soil or sediments via surface runoff in other areas as well. So the image that we have up on the screen here is an image that indicates a large stormwater event triggered by triggering erosion that greatly increased the turbidity in nearshore environment over on Maui. That's not to say necessarily that this stormwater event or this erosion event was from a contaminated site. However, I think it really exemplifies how impactful excess soil can be in creating a contaminant of its own, in its own nature, or provide a visualization for how widespread the impacts of contaminated soil discharge can be due to unmanaged stormwater or unmanaged site soils. So we talked a little bit about the contaminants, how they get to where they are, and then how they spread beyond where they've been discharged into. Now we really want to connect the two together, which is through the lens of why it is important that we manage the stormwater and manage these potentially contaminated sites. Ultimately, it is in the interest of public and environmental health. So you've got your exposure routes, your direct contact, your potential for ingestion, inhalation, things of those natures. You've got your receptors, your human health, residential, occupational, things of those. Potential recreational users in the areas, ecological receptors, whether that's avian, terrestrial, aquatic species, and a special notice to construction workers who are oftentimes put in a situation where they're working in these sites and have direct exposure to contaminants that may be present. Now, we've got defined up there exposure pathways, which is ultimately the completion or connection between a contaminant source via a migration pathway to an exposure route that connects to a receptor. So calling special attention to the Department of Health. They have their health hazard and evaluation emergency response office that has established these environmental action levels or EALs that are meant to guide hazard exposure assessment. We want those to serve as a bit of a jumping off point for understanding how contaminants are evaluated as contamination on a site. And Dennis and I were talking about this yesterday. The way that we can view contaminants is that oftentimes they are naturally occurring or they may exist on sites at levels that have not presented a higher risk level. But through these EALs, we can better understand when contaminants have accumulated to the point that they now present a source of contamination and need to be addressed or managed. And so this image that we have here likely doesn't match the rest of the presentation directly, but we wanted to call special attention to an emerging contaminant that it's weird to say that I have a favorite contaminant, I suppose, but one that's of special interest to me and Dennis as of late in 6-ppdq, namely because it is widely found in the production of tires and ultimately is left behind through everyday use, right? The general wear and tear that comes from just driving on roads. So it's an easy to imagine example of how everyday usage can lead to an accumulation of a contaminant, maybe on a road surface that's discharged due to stormwater, finding its way into roadside drains or roadside soils, where it will accumulate even further over time and then lead to a case of potential contamination that can then further be mobilized into groundwater, nearby streams, and ultimately the nearshore environment as well. It's worth noting that 6-ppdq does not have an EAL at this point put out by the Department of Health. It is something that is heavily studied up in the Pacific Northwest, but we really just don't quite know what we don't know about it here in Hawaii. So we wanted to call special attention to that one. I'll pass it over to Dennis for the next couple slides.
All right, thanks, Derek. So with that sort of background or backdrop, if you will, to this topic, we want to bring it into a little bit more airports specific context. So I'm going to cover a few slides here that just give some outlines and examples of some of the airport priorities and focuses that they've put into their policies related to this whole issue of trying to not have contamination being moved around to places it should not be, or we don't want it to be. So I will attempt to cover that as well as I can in just a few brief points. So first of all, looking at it from the stormwater perspective, airports has had a program for a while. And so there are some policies and approaches that have been in existence for a while and are not new, but they do help to address this concern about managing contamination in soil and groundwater in particular. So first of all, as it relates to the, I think we're on the wrong slide here, Derek. Did we go? Sorry. Okay, no, I'm sorry. First of all, look at it from the stormwater perspective. So one of the very first things that happens for an airport construction project is there's an analysis done to see if that project work is going to disturb soil or groundwater in an area of known or suspected construction. So right off the bat, it's being looked at in the process. I think this is getting more emphasis lately, but it's not a brand new thing. Next, the project is going to go, in and through the design stage. So there are some specific things that happen for stormwater management during construction and also post-construction that has been looked at for years. These things aren't new. So, are the right controls going to be in place for erosion control, or the right controls going to be in place to manage stormwater, runoff once the facility is constructed, et cetera. Green infrastructure, low impact design, development kinds of approaches. Knowing that you're in an area with contamination, that now has a little bit of a different twist, right? So you're still doing the same thing, but now you might be thinking about different concerns and solutions. And then, of course, projects go into construction, and then there's the construction inspection process. This has been in place for a while as well. But it's a little different when you're at a site that's got contamination, because you probably have some special controls. You've got measures in place to protect workers, et cetera. So these inspections now include other things than just sort of the straightforward construction BMPs that many of you are probably very used to. And then I just wanted to comment and mention, part of the construction project needs that you all face on your projects is the proper management of both clean fill and contaminated soil. And it's very routine now, I think probably for a lot of projects you may be working on, but certainly for airports, to have contaminated soil issues. And it may be marginally contaminated, it may be bad, but it doesn't matter, because there are very specific procedures. And the environmental section has worked with DOH to roll out some good guidelines and very specific kind of requirements to help contractors and construction management firms work through that process properly. Okay. Now, looking at it from the other perspective, more of the kind of contaminated site perspective, Airports has a programmatic environmental hazard evaluation, environmental hazard management plan document. This is programmatic in the sense that when you've got sites that don't necessarily have known contamination or kind of small and simple, they've got basic guidelines and they don't have to go through a whole involved planning process for those kinds of sites. However, quite often projects are of medium or larger complexity. They might need a more project-specific look. They might need a construction environmental hazard management plan that gets approved by the airports and approved by DOH. And that in of itself can be a whole process. So the kind of takeaway is if you're working on an airports project, be in communication and coordination with the environmental folks right up front so you can understand if you need to go through the programmatic process or a site-specific process. And that's usually going to be right on the designers right up front. There's some newer policies. You got the airports, you got large land areas, many of them near coastal environments, near shore environments. And so airports has taken very seriously concerns related to contamination in those environments, particularly the PFAS contaminants that come from AFFF, right? And because of the history of the airports, the history of fire training, the history of maybe accidents or discharges, who knows where that stuff is? So to establish, good procedures and protect the state's own liability, there is a process now basically treating any area before it's tested as if it's contaminated, right? So you got to really demonstrate it's not there because you don't know and you can't see it, smell it, or taste it. So it's not like you're gonna know unless you actually look for it the right way. So there are some newer policies out, and AREE at airports has worked very closely with the HERE office now for a number of years, but especially the last couple of years to kind of work through the needs of the state, both from the airport side as well as the environmental compliance side. And there's policy documents out about that. Okay. Follow the TGM. That's gonna be my last thing about this. DOH, if you haven't worked with them lately, have tightened up following or being in compliance with the TGM and the soil stockpile guidance. So if you're on the fringe of that world and haven't worked with the HERE office lately, please be prepared. Review times are probably going to be longer and the requirements are going to be greater. All right, I'm going to go to two projects real quick, just to give a couple of examples of DOTA construction projects where some of these issues came into play. So the first project I'm going to mention is the RF Station 2 out by K Lagoon. Basically, this is a fire training area site, so they definitely had AFFF usage out there. Over the last 3 years or so, they did removal of a UST that had jet fuel and related piping, and then components related to the actual firefighting training facility. Definitely PFAS present there, along with some hydrocarbons and other things. And so a couple of key concerns with that site were protecting the workers, and then also, because it was not a remediation project, it was a construction project with very specific kind of objectives related to facility improvements. There's going to be contamination left in the ground. So this particular site, one of the things that they did to help manage that was lay down a foot or so below the ground surface, I think it was 18 inches or something, a low permeability fabric, put some clean fill, asphalt cover, whatever on top, so the construction work could happen on top of that. And then also that went over any disturbed areas where there might be PFAS contamination in the ground, and that could help promote migration of stormwater away from that area instead of through that area, and continued flow from groundwater into the lagoon and the ocean. So that was that project. Another one, recent project is at Kahului Airport, also at the ARF training area, where they had some releases from the AFFF usage, and they had a bike path going through right next to that facility, and their levels of PFAS were high enough there were concerns for recreational exposure. So people walking that path, riding their bikes, stopping, whatever. So they excavated the top 2 feet. They put down a impermeable, membrane liner at the bottom of that excavation that served 2 purposes. First, it helps mitigate infiltration of stormwater back through the contaminated soil that's below that layer. But also in the future, if they ever come back into that area to do more work, remedial or other construction, they now can see what's clean versus what's dirty because they're preventing contact from the clean fill and the contaminated soil below. And that's a technique that DOH has been encouraging for a while. So bike path got rebuilt. Now there's no real direct exposure in that area, and there's some better mitigation of stormwater infiltration. So those are just a couple examples of some recent projects that kind of try to put some reality into what we're talking about here. But turn it back over to Derek, and he's going to kind of come back to some bigger picture issues about this.
So Dennis gave you a little bit of the nitty gritty of how this is working. I'm going to bring you right back out to a higher level view. You heard a little bit about how stormwater can infiltrate and how stormwater infiltration can be managed with a couple projects there at Department of Transportation airports. That's namely because there is a significant and understood connection between surface water and groundwater, where surface water can infiltrate through these contaminated media and directly into groundwater. And what oftentimes can be overlooked is that groundwater can eventually then transport those contaminants away from their source and introduce them back into surface water through things like base flows, springs, and ultimately discharge into the nearshore waters. Now, coming back into DOH, I know we've talked a little bit about it already. Their EALs are specifically linked to the proximity of a site to surface water or drinking water to establish limits based on a variable amount of risk. It is meant to allow for a better understanding of how your site can ultimately impact sensitive receptors based on its proximity to high usage things like potential drinking water aquifers, surface water for recreation, commercial use, industrial use, things of that nature, right? The image up on the screen here is meant to represent the UIC control line, which is an established and visualized way of understanding a site's location relative to a very specific sensitive receptor in an aquifer that is potentially used for drinking water. So you can see the UIC line there in blue. If you're evaluating your site and you see that it is, Mackay of that line, it is likely over an aquifer that is not used as doesn't have the potential to be used as a drinking water aquifer. Conversely, anything to the mountainside of that line has the potential to be over a drinking water aquifer and needs to be treated with greater deference to the potential risk of your site's potential contamination migration down into groundwater. So at this point, we've talked a lot about sites as they are now, contaminants, evaluating your sites as they are in their current condition. We want to also focus a little bit on making sure that you plan or you have the potential to plan for future impacts as well. Through that lens, we want to talk a little bit about how climate change and ultimately extreme weather considerations can allow you to, or giving those consideration can allow you to plan for the future as well. We talk a lot about it. We hear a lot about it. Extreme rainfall, flooding, and sea level rise, they do present amplified risk, especially in the context of airports, low-lying airports, places like H&L, ITO, OGG, JRF, things that are a little bit closer to sea level. And even more so when these events coincide with active construction, like we were talking about a few slides ago. So site-specific risk analysis is really needed. You can review your flood maps, the soil types for variable vulnerability, understanding the contaminant types and the locations that you're in. And an easy way to take a look at this, while just a few years back, DOH released a memorandum entitled "The Risk of Sea Level Rise and Increased Flooding on Known Chemical Contamination in Hawaii." Came out in 2021. They basically monitor or represent that they monitor over 1,000 contaminated sites, many of which that are located in low-lying areas, along shorelines, or at risk to coastal erosion, submersion, impact from flooding, and into the future, those impacts have the potential to become worse. So you see an image here that represents just a handful of those that are in a low-lying area around Honolulu Harbor, and the map represents areas that have the potential through modeling to be impacted by that 3.2-foot sea level rise. So you can see how many sites just in a small area have the potential to be additionally impacted in the future. So it's worth considering that as you're getting into the planning phases as well. Now, we've talked a lot about the contaminants, where they come from, how they get where they are, how they have the potential to move, what that planning might look like. But we also want to make sure that we give you some additional strategies beyond the ones that have already been employed, ways that you can design for the management of stormwater or the management of the contamination in site. So you've got things like pre-infiltration treatment, actually allowing the stormwater to be treated whether via bioretention or biofilters, before it actually comes into contact with contamination, by way of controlled versus uncontrolled infiltration. Controlled being kind of those constructed features that we talked a little bit about earlier, drainage wells, things like that, versus uncontrolled. Think your vegetated medians between roadways or the vegetated infields that you see out in the airfield. While they are constructed, the infiltration control is a little bit less structured, let's say, than if the water was finding its way into a drainage well. You've got the opportunity to employ something called first flush diversion, which is actually something that I encountered when I was first working in residential stormwater management back in Texas. I didn't realize until fairly recently that this is an opportunity for larger sites to employ a designed amount of stormwater that can be diverted away from discharge off-site, treated separately, and then anything beyond that coming into contact with either less contaminated or uncontaminated soils after the fact. So you can actually separate out the first amount of stormwater that hits your site versus the latter amount of stormwater that then doesn't come into contact with those like heavier amounts of contamination. You've got source separation and then the omnipresent maintenance. O&M is obviously very important. You may have systems in place on your site that are already being employed. So maintaining those systems, the filter media that are in place, really can't be more important when it comes to managing those contaminated sites. So lastly, you've got your stormwater management contaminated sites. Ultimately, our goal here is really to reduce ponding, divert sheet flow from the site, and prevent contact with contaminants. Now, I've been given my 5-minute warning, so I'll push my way through these really quick. We've talked about managing sites and how you can manage them as they are. There's also opportunities for multi-benefit opportunity here. That could be redeveloping your site that with a focus on restoring ecosystem services that can be allowed through revegetation, providing various community amenities through parks, green corridors, supporting climate resilience goals through carbon sequestration. A lot of these things can be employed in concurrence with managing the sites beyond just making sure that contaminants stay where they are, like the redevelopment of a bike path. So combining stormwater management with remediation. And then ultimately we wanted to call attention to a very interesting resource that we came upon, which is the EPA's Revitalization Ready Guide, which lays out a framework for how you can redevelop these sites with a higher and better use in mind. It lays out a framework for assessment, planning, and then implementation of their suggestions. So a couple key takeaways for you. We talked a lot about infiltration and how it is valuable, but obviously context dependent. It is a key way to manage stormwater, but needs to be the conditions of the site that you're infiltrating into need to be taken into consideration. Along with that, evaluation of the risks that are present through means of legacy pollutants, the infrastructure that's on site or adjacent to the site, and future risks that may be a part of the climate change and induced water change cycles that come, or water cycle changes that come along with that. We feel that these smarter designs are really a combination of proper treatment, potential for containment, and then the reuse of the stormwater that's finding its way onto your sites. And ultimately, our goal here is to protect groundwater, streams, and then ecosystem and human health along the way. So with that, we'd like to open it up to any questions that everybody may have. And really what we'd love to hear from anybody, if they're open to sharing, is if you've had any experience with these sorts of challenges or any innovations that you've been able to employ that have led you to be successful in managing your sites or your stormwater.
Jason from the Zoom says 60 millimeter geomembrane liner, not 60 mil, question mark.
60 versus 16, that was the question?
No, it's 60. I'm not really sure.
Okay. I suppose I'd have to go back and check the specs on the project specifics. But yeah, likely I would assume 16, not 60. Yeah.
It was more than Visqueen, but I can't remember. It could be we have a typo.
I think the intent was ultimately that the design of the geomembrane was such that permeability was minimized.
Yeah. I just wanted to add one other thing too. I had it on my slide as a bullet, but since we have a moment, because I did kind of skipped over it. One of the airport's policies around managing soil includes how soil reuse occurs. So if you read it on the slide, that's great. But I just wanted to highlight because of the concerns in particular about PFAS contamination and those uncertainties, Airports does just not want that soil going anywhere. So that's why we had the bullet up there about, no, none of that soil goes from airports to a school or residential area. But not just that, soil that comes off a site can't just be taken around to another area within the same airport, unless you get approval from the engineering and environmental section. So if you're working on airports projects, you may in the past have been able to move that soil around or take it back to the contractor's yard or do things like that. No longer. Okay, please don't do that without the proper coordination and approval. It may still be able to happen, but it's going to have to be properly tested and make sure contamination is not being spread around. So, yeah, thank you.
Dennis, I just had a follow-up question to that because I thought that the bullet point on your slide regarding that PFAS impacted soil said that it was landfilled. And so I was wondering whether the landfills are actually taking that versus having folks keep it in place and cap it.
Okay, so like landfilling in Hawaii could be its own topic of conversation. It's a great question. So interestingly, in my experience, the HERE office is they don't like to see that stuff get landfilled. In many respects, that contamination is better left managed in place. I mean, for one thing, you have landfill capacity, right? We've got issues with our two main landfills here, right? PVT landfill is kind of reaching the end of life, and the siting of a new landfill for the city and county has also been a bit of a concern, right? So solutions that don't involve landfilling are often going to be favorable and take a little bit more work to kind of think through. That said, there's still a lot of landfilling of that soil happening. It's happening here. It's happening on the Big Island. I think there's some project sites there. Maui soils are going to the landfill. And, not just from airports, but from other projects too. So for like long-term liability concerns, like landowners generally shouldn't like putting that stuff in a landfill because you're going to be on record from having put it there. But sometimes it's really still kind of like the only option that's economically viable.
All right. Well, then I'll say thank you very much, everybody, for joining. We really appreciate your time today. Special thanks to DOTA, and we hope you enjoy the rest of the conference.